hear me?
Yeah,
Shall we start now?
yeah, start.
Okay. Okay. Good evening, everyone. Myself, Jeevan, CD. My team members are Ananya, DRUTHI, and DEEKSHA. Our topic is Smart Blind Stick. Our contents are introduction, objectives, circuit diagram, components used, and the working principle, advantages, social impact, conclusion, and the final is the future scope. So, I will be explaining the introduction and the objectives. So, introduction. The blind stick is an electronic assistive device designed to support visually impaired individuals. Users uses like Arduino Uno and the ultrasonic sensing technology to detect the obstacles ahead. Provide audio like a buzzer and tacticals like a vibrations alert for the safe navigation. Aims to enhance independence, safety, and confidence for the users. So next will be the objectives. To design a relatable smart stick using the ultrasonic sensor technology to alert the user instantly about nearable obstacles using buzzer and the vibration motor. So in this, we will attach the buzzer and the vibration motor in the stick. So from that the person can know that the obstacle is in front of him. So next is the to build a low power, portable and the affordable devices. Next is the to improve the safety and mobility of the visually impaired individuals. So next will be continued by Dhruti.
Hi ma'am, I'm Dhruti and I'll be explaining the circuit diagram. So this diagram shows an Arduino based distance detection system using an ultrasonic sensor and a buzzer. So Arduino Uno is the main controller and the ultrasonic sensor measures distance and the buzzer gives an alert. And here you can see the Arduino Uno. It is the brain of the circuit and Arduino supplies power to the component so that it sends trigger signals to the sensor and receives echo signals and controls the buzzer. And here you can see the VCC, which is of 5 volt, which is VCC stands for voltage common collector, and VCC is connected to the 5-volt pin of Arduino to power the sensor, and the trig means digital pin 10. The trigger pin is connected to pin 10, and Arduino sends a signal through this pin to transmit ultrasonic waves, and echo, which is of digital pin 9, and the echo pin is connected to pin 9 and it receives the reflected ultrasonic waves back. And GND, which stands for ground. So ground is connected to Arduino ground to complete the circuit. And here you can see the buzzer. So it acts as an alert device for the blind person, so and it will be very useful for them. And one terminal of the buzzer is connected to an Arduino digital pin and the other is connected to the ground. So when an object comes close, the Arduino turns on and the buzzer it will vibrates. And first Arduino sends a signal to the trigger pin and then the sensor emits ultrasonic waves and then waves hits the objects and reflects back, and then echo pin receives the signal and Arduino calculates the distance, and then if the distance is less the buzzer sounds. And so the diagram clearly shows how we can how the blind stick works. And moving on to the next slide. So components used. First we have used is Arduino Uno. So Arduino Uno is the main microcontroller and acts as the brain of the system, as I told. So it processes the signal received from the ultrasonic sensor and controls the output devices like the buzzer and the vibration motor. And second is the ultrasonic sensor, which is of HC SR04. The HC SR04 ultrasonic sensor is used to detect the distance of nearby obstacles, and it works by sending ultrasonic sound waves and receiving the reflected waves back. And based on time taken, it calculates how far the object is and detects it. And then 9-volt battery. So the 9-volt battery provides power supply to the circuit and it allows the system to work independently without continuous USB connection. And fourth is the buzzer. So the buzzer is used as an Arduino alert device. So when an obstacle comes closer than the set distance, and the buzzer produces a sound. which is very useful for the blind people, and this wants the users immediately. And fifth is a vibration motor. So the vibration motor provides tactile feedback, which is like it is used in silent mode or for visually impaired users, and instead of sound, the user feels vibration as an alert. And sixth is a connecting wires and stick frame. So connecting wires are used to connect all components properly, and the stick frame helps in mounting and holding the components together, and this improves stability and structure of the project. And next slide will be continued by Jeevan.
So next I will be continuing the working principle. So in this page we can see the our demonstration of the project. That is, we attach the Arduino and the ultrasonic sensor, buzzer, and the battery to the stick with the connecting wires. So in that, ultrasonic sensor emits the sound waves and calculate the distance based on the echo time. So and the Arduino receives the distance that receives the distance data and compare it with the set of a threshold. If the obstacles is within the unsafe range, the buzzer beep to the alert users, and vibrator motor vibrates for the additional feedback. So from the motor, the stick will be vibrating so that the blind person can notice that, and from the buzzer, he will move aside in the safe moment, safe road. Then the user is warned easily and can avoid the obstacle safely. So next will be continued by Deeksha.
Hello, ma'am. I will be explaining the advantages and social impact in the system. The system is affordable and easy to build, so it can be used by many people, and it can detect obstacles from a distance, helping users and avoid collisions. It has a dual alert system, which means it gives warnings through sound and vibration. It helps user move independently without depending on others, and this device is lightweight and comfortable to carry for daily use. It works well both indoors and outdoors, making it practical in real life situation. And next slide. Next. Social impact. This system helps usually impaired people move more freely and safely. It reduces dependency on others for navigation and support. It prevents accidents and improves safety in public places, and it promotes inclusivity and improves the quality of life for users. Since it is low cost, and it can be mass produced and made available to society easily. Thank you. Next slide will be continued by Ananya.
Hello, ma'am. I am Ananya. So I'll be doing the conclusion and future scope. Now, coming to the conclusion of our project, the Smart Blind Stick is a simple and practical assistive device designed to help visually impaired peoples to move safely and confidently. In this project, we use Arduino board, ultrasonic sensor, and alerts like buzzer. The ultrasonic sensor continuously checks for obstacles in front of the user. Whenever an object is detected with a short distance, the system immediately alerts through sound. This provides real-time feedback which helps the user avoid collisions. The major advantage of our system is that it is effective, lightweight, and easy to use. It can be built using easy available components, which made it affordable for the users. Moving on to the next slide. Future scope. First, we can add in GPS navigation, which helps user with real-time location tracking. Second, additional sensor like water detection, optic detection, or light sensor can be integrated to handle more real-world situations such as steps or low light environment. Third, we can introduce voice output where the stick can give spoken instruction instead of buzzer or vibration, which makes user more friendly. We can also replace the regular battery with rechargeable batteries or solar charging, which will increase the reduce maintenance and portability. Finally, advanced features like AI-based object recognition can be implemented to identify specific objects and provide smarter assistant. Thank you, ma'am.
Done, everyone?
Yeah, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. I have some doubt.
Yeah,
Like
ma'am.
it won't
Yes, ma'am.
detect water right now, and you will be implementing further future, right?
Yeah, ma'am.
Yes, ma'am.
Then what about light theme? Like, does it work on low light?
Yeah, ma'am. It does not depends
Yes,
upon
ma'am.
the light and
Yes.
nothing, ma'am. We
Then you
can
add
we can
future.
use in everywhere, ma'am.
Okay. Show that last slide. Future scope.
Wait a minute, ma'am.
Hmm. Mm, integrating water detection, pit detection, or light sensors. Then you added all those things in future scope, right?
Yeah, ma'am.
Yes, ma'am.
Yes, ma'am.
If we want, we can implement in the future, ma'am.
Hmm. Now it doesn't work, right?
No, ma'am. We
No, ma'am.
didn't implement light sensors and water detection
Mm-hmm.
sensors, ma'am.
Okay. What happens if the path is more upwards and downwards? Can it detect?
For that, ma'am, the person will also experience that the up and down road, ma'am. For
Hmm.
that, we didn't implement, ma'am. If any, for example, if any big rocks came in between the roads, that it will detect the object and it will make the sound like a buzzer.
Mm-hmm. Okay, pa.
Ma'am, I have some doubts in making the reports, ma'am. After
Hmm.
that meeting, I will. Can I ask in this meet only, ma'am? After I will stop it by stopping the read AI.
Present.
Yeah, yeah, you can ask.
Okay.
Mm.